Hello everyone, welcome back to another AP Physics 1 energy problem. Today we'll be doing the number 3 in the MIT AP Physics 1 workbook that will be linked in the description down below for you guys to also practice. With that being said, let's go ahead and read the problem. It says a 2 kilogram ball is attached to a 0.8 meter string and whirled in a horizontal circle at a constant speed of 6 meters per second. The work done on the ball during each revolution is... So now we have to take into account this thing. It says right here, whirled in a horizontal circle at a constant speed of 6 meters per second. So we know that has to do something with centripetal force. So we're going to draw ahead and draw our circle, horizontal circle, and it says attached to a 0.8 meter string. So here we have the stick or whatever the string is attached to. We have our string going here, and then we have our ball. So this is a 2 kg ball. So I'll just write 2 kg. And then this string, which is 0.80 meters. And in this case, when this ball spins, we have two forces acting on it. We have the force tension, which is our force centripetal, the force keeping it in the circular motion. And then we also have force gravity acting on the ball. We also have force gravity acting on the ball downwards. And now it's asking us what the work done is. And if we remember, our work equation is work is equal to force times distance times the cosine of theta. And then we need to remember that the theta is the angle. So theta, or let me just write angle. Let me just write how. Angle between the force and just the motion, or the direction vector is what people call it, but the motion to keep it more simple. So as this ball goes around, it's going to travel in this circular motion like this, right? But there's one thing we need to know and to keep, sorry, not to know, but there's one thing we need to keep in mind. This force gravity is going to be pulling the ball downwards. And if we're traveling this way and the force gravity is down this way, the angle is going to be this theta right here. And what this is it's perpendicular. And since it's perpendicular, it's going to make a 90-degree angle. And if you remember your unit circle, which you don't have to because you do have a calculator on the AP exam, so you can just go and calculate cosine of 90. But if you remember on your unit circle that a 90-degree angle, cosine is right here, is going to be 0 because cosine is the x-axis. And right here, this 90-degree is going to be 0 on the unit circle. So it's going to just equal to 0. And if this equals to 0, cosine 0 is 0, this whole side becomes 0, meaning that the work also becomes 0. And we can do the same thing um, for the force tension. We see that the object is traveling this way, and then we have the force tension acting over here. If we draw our angle right here, the theta, we see that it's perpendicular. And since it's perpendicular, it's going to be 90 degrees. And this time, well, let's try to do it with our calculator. If we plug in cosine of 90, we'll get that it equals to 0. And as I said earlier, if this equals to 0, then this will all equal to 0, meaning the work also equals to 0. And knowing that both equal to 0, that means that the total work done is going to be D, 0. Because there's no work done, since both forces are perpendicular to the motion, it's going to be 0 and add no motion. Sorry, not no motion, but it's going to add no work done because of this cosine theta. So that's something we have to keep in mind. And because it's cosine theta, we need to remember that any force that is perpendicular is going to add no work to the equation, which is why we lead to choice D. I hope you guys enjoyed this video. If there's anything that you didn't understand or was complicated, please comment down below and I'd love to explain it to you guys. Please forgive me for my voice. I understand it might be very annoying. I'm a bit under the weather, but I promise to get back ready and for you guys. I hope you guys enjoyed the video, and remember to continue your prep, and remember to enjoy life.